Yeah. We're talking about experimental probability today. So experimental probability, it's different than theoretical probability. Sometimes it's called empirical probability. It's pretty straightforward. Initially, it won't make much sense, but in the end, this is actually what we do with statistics all the time, is we try and determine the probability of an event happening experimentally, probably because we can't work it out theoretically. Here's the formula for those of you who love formulas. The probability of an event of interest, so that event is A, like drawing an ace, for example, is equal to the number of times we draw or see event A happen over the total number of trials that we do. So we're doing an experiment over and over again. We're seeing how many outcomes of interest are happening divided by the total number of outcomes, okay? And it can be inaccurate. But if we do it right, and we do it using statistics, we can actually come up really close to the actual probability. So using this giant deck of cards, let's see what the probability of drawing ace out is. Oh, no cards up my sleeve. Okay. So experimental probability. We're going to do a trial here, and oh, look at that. So right now, with this small number of trials, the experimental probability of drawing an ace, well, let's see. The number of times I've drawn an ace is once, and the total number of trials is 1. And so apparently the experimental probability of drawing an ace at this point is 100%. Now, are there problems with what I've just done? Or is this deck 100% aces, or could there be something else going on here? Or should I do something else? Anybody? If you said I need more trials, you're probably right. Okay. Yeah, I need more trials in order to determine this experimental probability. So and oh my goodness, I don't even know. This is horrifying. This is one of those clown things that scare children. It's a mime. No, it's a joker. Just kidding. Okay, so by increasing the number of trials right now, the experimental probability of drawing an ace comes out to 50%. So I drew an ace once. I've done 2 trials. 50%, or 1/2. Okay. I'm going to do another trial. Anyway, and then this will be the last one. Yes. All right. It's not an ace. Okay. If I did enough times, eventually my experimental probability would get really close to the actual probability of drawing an ace. If I had a deck of cards, I would probably already know what the theoretical probability was and work it out from there. But in a lot of cases, like if I want to know what's the probability of selecting, say, a smoker out of a population, I'm going to have to go with an experimental probability. Anyways, fairly simple. Number of outcomes of interest divided by the total number of trials gives me the experimental or the empirical probability. The probability of all of the outcomes has to add up to 1. And that's it. It's experimental probability. That's easy.